So we are going to do the integral from 0 to -1 of the square root of 1 plus x minus 2 times the sixth root of 1 plus x, all divided by the cube of 1 plus x plus 1. Now, when I look at this integral, I see that we have a lot of roots. So that gives me the idea of substituting some kind of square root to help us out. But in addition, there's something very specific about these roots in particular, which is we have a sixth root here, and then we have a second root, a square root, and a cube root. And I know that 2 times 3 is 6. So if I substitute u equals the sixth root of 1 plus x, the cube root of 1 plus x is going to be u squared. And the square root of 1 plus x is going to be u cubed. So we can turn this entire thing into a polynomial. Now what's especially cool about substituting roots like this is that if we take the sixth power on both sides, so u to the sixth equals 1 plus x, and then subtract 1, so u to the sixth minus 1 equals x. Now we can differentiate both sides to get dx, and we'll again be left only with a polynomial that we can substitute in. And therefore, we'll turn this whole integral into a rational expression, which is much nicer to deal with. So let's plug this all in. The sixth root of 1 plus 0, well, the sixth root of 1 is just 1. And then the sixth root of 1 plus -1, sixth root of 0, is just 0. Now let's look at this. The square root of 1 plus x is going to be the sixth root cubed. So we get u cubed minus 2, and then the sixth root is u, over the cube root is going to be the sixth root squared plus 1, and then dx is 6u to the fifth du. And now what we're going to do is take this 6 to the outside because it's just a constant, and then we'll multiply this u to the fifth through the numerator. So we'll get 6 times the integral from 1 to 0 of u to the eighth, u to the fifth times u cubed, minus 2u, and then 5 plus 1 is 6, over u squared plus 1 du. From here, we see that we have a rational expression where the power on the top is greater than the power on the bottom, which means that it's time to do some polynomial long division. So let's take a look at this polynomial long division right over here. And to start out, we want to get u to the eighth out of this u squared. We're going to need to multiply by u to the sixth. So we'll take out u to the sixth, and that will become u to the eighth, and then plus u to the sixth is what this 1 will turn into. We subtract these, get -3 u to the sixth coming out. Now we want to get -3 u to the sixth. That's going to require -3 u to the fourth times this u squared to get us there. So we'll get minus -3 u to the sixth, and then minus 3u to the fourth is our 1. Subtract those, these cancel out, we get 3u to the fourth coming out, and then we'll just keep going down. So you get minus 3u to the fourth plus 3u squared. That'll be our next term here. And then subtract these, we get minus 3u squared, and then we're almost done. If we want to get this, we just have to multiply u squared by -3. So you get minus -3u squared minus 3. And then we're just going to be left with a 3. And at this point, 3 is not something we can get out of u squared plus 1. So this is when we finish the division and say that our final result has 3 over u squared plus 1 as the final term. So let's give ourselves some more space to do the integral. We're going to do the integral from 1 to 0 of the result that we get right here. And we have the 6 at the beginning, integral from 1 to 0. Then we get u to the sixth minus 3u to the fourth plus 3u squared minus 3 plus 3 over u squared plus 1 du. So this is our integral expression that we got from the long division. And now it's time to integrate because all of these are fairly simple to do. So first of all, we'll get 6. U to the sixth, we apply the power rule, get u to the seventh over 7. Then we keep doing that. 3u to the fifth over 5 plus 3u cubed over 3 is just going to become u cubed minus 3u plus, and then the integral of 1 over u squared plus 1 is going to be the inverse tangent of u. Then we evaluate that at 0 and 1. Notice that when we evaluate at 0, all of these are going to be going away. So 0 to the seventh is 0, 0 cubed is 0, and the inverse tangent of 0 is also 0. So we just have to consider this lower bound here. we're going to get negative 6, because when we do the lower bound, we're subtracting it. And then we'll have 1 over 7 minus 3 over 5, just plugging in 1 here, plus 1 minus 3. And then the inverse tangent of 1 is pi over 4. Just like that. So at this point, the rest of the problem just becomes adding, and I trust that since we're doing integrals like this, we all know how to add fractions. So I'll just skip to the answer right here. The final result is 516 over 35 minus 9 pi over 2. So in this case, the way we got to this answer was we started with our integral, noticed that all of our roots have this common factor, so that when we use the 6th root, we can write all of them just as u squared, u cubed, and so on. And then once we got to u to the 8th over u squared plus 1, we were able to use polynomial long division to simplify it down and then use some basic power rules and integration just like this.